So very good afternoon to all the participants. Now we are having very eminent personality, Dr. Ashok Sharma ji with us, and he is the chairman of Clean Tech International Foundation, Shimla, and he is one of our guest faculty over here in NITER Chandigarh also, and he has been instrumental in submitting various projects in civil engineering department of NITER Chandigarh, and prior to that he was ex-chairman pollution control board. So he has worked on different technological aspects, different technological interventions. So today he will deliver his talk on innovative technological interventions for smart city management. So now I would like to request Dr. Sanjay Sharma to kindly say a few words.
Good afternoon and welcome Dr. Ashok Sharma ji for this session on a very interesting topic on innovative technology interventions for smart city management. We have been seeing that the IoT applications and like in particular area GIS applications. What basically from technology point of view, what are the interventions can be taken so that we can make our cities much better and make the cities smarter also. So Dr. Sharma, as Amit has said that we have established one of the center here, that is a Center for Clean Technology and Sustainable Development, and he has been the guiding force for establishing this center, and particularly these programs like on the latest techniques of smart cities, solid waste, and some clean technologies, etc. We have been basically conducting this program in association with Clean Tech International Foundation. And also we are, with the help of Dr. Sharma, we are basically identifying many times some industrial problems, and through those, through his expertise, we are giving the solution to many industries for solving their problems, like maybe in terms of say solid waste, in terms of water, and Dr. Sharma, as he said, he has a very wide experience in the area of say offering the green solutions, like pollution prevention techniques, telling the industries about pollution prevention techniques. So that means that we are trying to control the pollution at the source itself. So so I think his lecture is always very interesting and and he gives very innovative solutions. So, and that is why this topic is also an innovative technology intervention for smart cities. So I hope that we are going to have a very good interaction and good knowledgeable sort of a presentation from Dr. Sharma. So I welcome you, sir, for this presentation, and thank you very much for accepting our invitation. So, so over to you, sir. Thank you.
Thank you, Sanjay. I can't see you guys, so I just talking to the air. All right, and thank you for calling me to give this presentation at a very short notice. I would, before I start, like to know what kind of participation is there with us, what level of people, and whether technical people or the administrators. Just a composition of the group.
Sir, we are having AEs, JEs, and SDOs from different departments. We are having 10 participants from Rural Development and Panchayati Raj from Tamil Nadu, and we are having participants from Punjab Police Housing Corporation, and we are having participants from the Civil Engineering Division, Construction Division, UT, Chandigarh, and few participants are from teaching side, from from research areas, and few are from few scientists are from CSIO. So we are having around 20 to 23 participants in this program, sir.
Good. Guys, you would all notice that we got a smart coordinator for the smart city management project on your training program. That is Dr. Amit. So since I can't see you on the screen, Let me start by saying uh, I have been introduced to you and rather very lavishly. I don't really deserve that kind of uh, words of what have been conferred on me. But I would nevertheless like to share with you my views on this subject. As you know, smart city is something which is even the smart city management doesn't know what it really means. So there's no fixed definition of smart city. You know, creating an infrastructure to do things better than before on continuous basis. That's smartness. From going to banks and uh, participating in long transactions, we came to ATMs, from there to our mobile banking. And these are smarter ways of doing things than before. So likewise, smart city is one where we perceive all these smart moves. For example, if the street light is on, it should be switched on automatically when it is required and switched off when not required. And what do you do for that? Rest of everything in the entire infrastructure is the same. But you have a sensor which feels now the lights need to be switched on. So it'll do that. And whenever you think it's not required, it'll switch off. You have water supply going on into your tank. You need to keep a watch on it. When enough water is there, you can switch off the supply. But alternatively, there can be a sensor which automatically switches on and switch off. So it will conserve water. In the earlier case, it would conserve electricity. Now it will conserve water. And we become smarter and smarter, managing ourselves, our resources, our needs, our infrastructure. And so there are endless number of initiatives which can be adopted for making our cities smarter. When I say smart city, it means smart as of now, but tomorrow it has to be smarter and smarter still the day after. So it'll go on and on and on. Now, another aspect of smart city is that all these possible initiatives, whether using good construction material or using smart management systems, using artificial intelligence, using process controllers, everything, all these initiatives may be imagined and integrated into our plan for either creating a new city, which is a smart city, or making our existing city smarter. So they are both the ways of creating smart cities and then go on with it. You will, in this program, come across various experts. Somebody will come from energy sector. He will talk about smart grid. He will talk about the process controllers to manage energy efficiently. Yet another one will come from the water supply, and he will talk about how water supply system could be made more efficient, more imaginative, and in other words, smarter. A third one will talk about traffic management, how to avoid congestions, how to best manage your traffic, and thereby save the energy again. Also, somebody might talk to you about e-mobility. Rather than using fuel, diesel or petrol, and creating environmental impact, maybe e-vehicle would be a smarter move. But to have that smarter move, we need the charging stations. to cater to the new types of vehicles. So likewise, different experts will talk to you on different aspects of management. Some may talk of the garbage management. Some may talk of, if I'm talking of water, somebody may talk about drinking water, another person may water irrigation water, so the third person may talk about the sewage or wastewater. So I thought of going a little different from others and to just pick up one single term that is called innovation. So whatever our experts are contributing, it's great. I'm no expert and I don't claim to be, but then we can probably add some new dimension to the knowledge which is already existing, which is being very well provided to us by the experts we come across. And as a matter of fact, you all are experts in your own way. You are the guys who are going to implement this smart city. You are the guys who are going to manage this smart city. You are the guys who are designing. You are the guys who are implementing. So each one of you in his own area of expertise is an expert, whether on the water side or on the air environment side, health management side, education management side, mobility, the environment. So all of you are experts, but small improvements can be made every day by just thinking smart. And what is thinking smart? That is innovation. When I say innovation, I'm not an inventor who brought in something new, but maybe an existing knowledge is being channelized to do things better. So let's have a look at what are the various areas where innovation could be very easily. Innovation can be introduced anywhere and everywhere. I already said that. But then let us pick up a few areas of focus where we think it will make a great lot of difference. So let's talk of some major technology initiatives. As I said, to do things smart, we need sensors to gauge what is being done, and then do things smartly, for which we need what? Artificial intelligence. So a great combination of these two things can make our cities smarter and better, more efficiently managed. Again, we have initiatives like big data application, cloud computing, blockchain technology, Internet of Things, which means we club together knowledge in different segments, bring them together in a sequential manner, in a logical format, and then integrate them into the smartness concept of city building. Now, sustainable mobility and traffic management assets. A lot of initiative to be taken. Many people, experts will come and talk to you about it. Similarly, sustainable waste management infrastructure. Most of our cities fail here. With affluence rising, we're creating so much of waste that we are unable to handle it. And we never thought we will be doing this. We never created such infrastructure in the past. So in a new city plan, maybe every house has a garbage bin which is connected to, let's say, a vacuum system where the garbage is sucked away to one central station. And there it is handled professionally, like it is handled in a factory, which is segregating, processing, recycling, reusing the waste and adding value to it. Maybe some part of the waste will go for reclamation of materials. Some part of the waste might eventually be burnt to generate heat, and that heat might generate electricity, which we can use ourselves. So all these initiatives when we plan in the city building is smartness. So sustainable waste management is going to be very important. I'm going to pick it from all these lists. Possibly I cannot take all of them. Firstly, not being an expert on every subject. Secondly, in this small session, we cannot possibly cover all these aspects. So sustainable waste management is one I offer to pick up. Similarly, there is very important aspect of city management, water quality management and conservation. When I say water quality, I already said it can be groundwater, it can be raw water, it can be treated water for drinking, it can be a wastewater thrown out after consumption and use. So there are many types of water which we are going to handle, and we need to maintain a water circuit where the water goes again and again and again reused and recycled. Similarly, energy efficiency, sustainability. I gave you the simplest example of having sensors to switch on and switch off street lights. But this is required in official buildings. It is required, when you go to very large buildings, you have lights along the walkway. So there are sensors where as you walking in the corridor, these lights go on, getting switched. You go to a toilet, you wash your hands, put them below the dryer, it dries your hands, then you walk off, it shuts off. So energy efficiency and sustainability is a very, very important aspect of smart city. Now, their energy efficiency and sustainability, I would look at differently. Energy efficiency is like this use of sensors I mentioned. You make a very efficient use of energy, you conserve energy, and you reduce your costs, and you also cause lower emissions. But when you're talking about sustainability, another dimension is added, not just conservation of energy, but also alternative sources of energy. That becomes a very, very important field by itself. And I would say, for taking an example, solar energy should be our top priority in building our future cities. This is one area where we have not made any headway, I would say. Some of you might think that we have solar cells at home, we have solar cells in the fields. How do you say they've not been? But no, it is highly insignificant use of solar energy as an alternative source. Sun gives so much of energy to us that we can be self-sufficient to meet all our requirements. Let us believe in that fundamental. But we are not able to tap it. This heat is scorching us during summer. We need to get shade, we need to get air conditioning. And again, during winter, we are not able to tap it to our best advantage. I would imagine a city with all these shopping malls, parking areas, entirely created of solar panels. Wherever we need a roof, a solar panel is the answer, which gives us the shade, which gives us the shelter, which generates energy for us. And mind you, solar energy is a free energy. So any building of future should be almost entirely built of solar panels. No, sometimes you may say it is not possible, but then there is another aspect to it, which is called the solar passive buildings. If you have something like a greenhouse, which we are very familiar with, what is it? It is taking in the solar energy, not allowing it to go back, and then using it and particularly in the hills, it's very, very important to have solar passive buildings. So sun gives us two types of energies, the light and the heat. So we need to use both of them separately in a balanced manner. When it comes to plains, we have to cut the supply of heat and use it maybe for cooling purposes. There are cooling systems which are fed with heat and which generate low temperature. So this will be an ideal place to implement such initiative. I give you an example of the dairy industry of Denmark. The Danish have a lot of cows, and like us, not cows for the milk, but for meat. So they have automated systems, the slaughterhouses, to make the best use of everything that is available in cow as a material. And in the process, milk becomes a byproduct with them. So they have a lot of milk, as much as they cannot consume. And they make milk products, the cheese, the butter, and sell it to the entire world. And all these storage facilities in that country are based on solar refrigeration. Now, this is a very smart move taken much earlier. We only have to transplant it here. So they are doing this in a cold country where very little sun is there, but using that solar energy for refrigeration. Their ambient temperature is very low. So when it goes above 4 degrees, the solar system starts working and cooling. And when it is very cold, foggy, there is no sun, it is already so cold that they don't need to refrigerate. Right? Same way in India. During 1980s, I tried to bring in from Denmark some equipment on donation. And where did we use that solar refrigeration? Near Hyderabad, we made these small ice cream carts to store cold drinks. So the man has a cart, he's going in the scorching sun, is shaded with the solar panel. It gives him shade, it gives shade to the customer. So on a remote village bus stop, he has a cold drink or cold water cart. So people in the scorching heat get a shade. They all gathered around him. The harder the sun, the colder the drink. So he's able to sell cold drinks without any source of plug-in energy, straight away from heat of the sun, right? So we can use solar energy to our best advantage, both in terms of heat as well as photons, which in our solar panels generate electricity. Ideally speaking, even roads should be, in many cases, when you have highways with very little traffic, the road can be such that it has solar panels all along and generate electricity. Any possible place where we need a shelter, a roof, particularly your bicycle parking, car parking, or motorbike parking, all parking should be made of solar panels. So while designing a city which is smart, This has to be kept in mind. You have big malls which have glass, but instead of the glass, if you had solar lining. Now these days, we have nano paints, which can be just roller painted on your window glass to convert it into a solar panel. Science has gone that way. So it's a very innovative thing that all of our windows could be converted into solar panels. Even our curtains in our house, it could have small solar cells which are interconnected with thread. And when you put on the blinds, they are generating power. So again, air quality assurance, noise control, our people from environment will talk about it. And it is very important, of course. Sustainable infrastructure would largely depend upon sustainable, or what we call it, eco materials. That's another area I like to choose today to discuss with you. I cannot, as I said, discuss all of them, but we can talk about definitely the water quality management, the waste management, and now I said eco materials, because these are things very close to our ecology. So I would love to take them. Then is the food security, vegetation, healthcare, community services, and recreation infrastructure, and ultimately the human resource management. So as I said, we picked up a few, 3 or 4 major areas of technology where we could introduce innovation, and we will start talking about them one by one. So I'm just reproducing what I said: water quality management, waste management technologies, smart materials, smart energy management, solar energy initiatives, smart tourism and recreation, smart mobility, and surveillance and coordination. That's where I said the big data comes into picture. How many tourists are coming? How many visitors are coming every day into the city? We need to provide for them, and for which we need to build an infrastructure to keep a watch on this data, compile this data, and then that's what we say, the big data analysis. So let's go one by one to first the smart water quality management. I said water means fresh water, raw water, treated water for drinking or bathing, used water or wastewater, and eventually treated water for discharge or recycling, for which technology becomes very important. We are all familiar with water treatment technologies. You guys are working directly or indirectly into this field, and we are all aware, by and large in India, we are only filtering and sometimes chlorinating water and giving it to people to drink. It's criminal. It's really criminal. And so many years after independence, we have not realized that chlorine is one of the deadliest things we could offer to people as a drink. One might argue that if the water is infected, if it has bacteria, viruses, vectors, it has to be disinfected. So chlorine is the answer. Well, no, it's not the answer. It was an answer and it is an outdated answer. Basically, when we talk of disinfection or we talk of water treatment, the most important underlying principle is oxidation. So kindly bear in mind, all of you, when you go back to your work, wherever you have chlorination as a disinfection technique in maintaining water quality, please abandon it as early as possible. Pressurize your management, build up opinions against chlorine use, and then try introduce ozone technology. Many people have a misnomer that it is very expensive. It's not. It's cheaper than sometimes chlorine. Why? Because chlorine has to be carried to your water supply system and then fed. Whether you're using bleaching powder or you're using chlorine or you're using chlorine dioxide, any derivative, it has to be brought to the site for treatment of water. Whereas ozone is generated on the spot. Even if an ozone generator is slightly more expensive than the chlorinator, for all times to come, you're getting free supply of ozone from the air. It takes oxygen from the air, which is available to an extent of 20% of the air, and passes through a cold corona discharge, and it becomes O3 from O2. And then it dissociates into O2 plus O. So oxygen in any case is good, but nascent oxygen is a very rapid disinfectant. In fact, the strongest amongst the strongest disinfectants. And in this case, it is cheaply available. Older days, when we tried to introduce this technology, it was not available in the country. It was very expensive, so there was a lobby against it. But today, with the indigenization of ozone or ozonizers, almost every kitchen is installing an ozone generator. So if everybody in the household has to install an ozonizer to disinfect his water, why not do it centrally in the smart city? So kindly consider ozone is a 100% disinfectant, means it kills all kinds of bacteria, viruses, fungi, or vectors altogether. And then, unlike chlorine, it does not have residual chlorine inside water left. It has oxygen, which is in the dissolved form, which means you are supplying oxygenated water, which is a healthy water. So this is one initiative on which I would like to strongly emphasize, and kindly keep it in mind when you go back, make enough effort at your command to bring about this small change which will affect the lives of people in your city. Water conservation and recycling, we have absolutely no second thought about it. And there are well-known practices. There are more like practices which are there. But when it comes to wastewater being used, recycled into fresh water, then we have something called the membrane technology, the reverse osmosis technology, the RO system. And these days we have much better technique in the form of nanofiltration. So the size of the pores of the filter is so small that no bacteria can pass through, no contaminant can pass through, and what you get across the membrane is clean water. So there are techniques like ozone. Let me conclude by saying that a membrane plus ozone can convert any gutter water into drinking water. And to give you the best example, I would say those who go in the space shuttle for 6 months or more, stay inside that, they cannot throw away sewage in the open environment. So they drink their own sewage water, their own urine, after membrane and ozone, and then they consume it. It is a safe drinking water. Technically, water is H2. It may come from a gutter, it may come from a sewage system. Eventually, if it is cleaned properly, filtered 100%, and then disinfected by using ozone as a disinfectant, it can be a drinking water. And to give you another example, most of the bottled water which you drink, which they claim to be WHO standards and which is sometimes ozonized, they write on that. It comes from groundwater which is highly polluted. And how they use it? Membrane and ozone. Now this is about treatment, conservation, and recycling. But very important is pricing of water as a strategic tool. So conservation can be motivated by pricing. So pricing cannot be very harsh, but at the same time, pricing should not be so low that people tend to waste water, throw water, spoil water. So this is a very important aspect. We need to change our mindset about pricing. Friends, I lived in Japan for 6 years and I was teaching in the Kyoto University. I observed that when I pay for my utilities in the house, the cheapest thing would be gas. Little more expensive, electricity. And very, very expensive was water. So I asked my host, what is this? In our country, it is just the other way around. He said, look, when you flush in your toilet, you are inviting fresh water, which is metered and charged as fresh water. And at the same time, you are discharging into sewage stream. And that is also metered. So you are paying two bills. So you're paying for the water which you used and you are paying for the water which you threw. So if I am taking water for drinking, I pay once. If I am using water for washing, I pay twice. If I'm using the water for flushing in the toilet, then I pay the maximum bill. Because I am charged the cost of treatment of the sewage water right at source. So this is how they brought into their culture water conservation. So when they use the bathtub, the family, they have a shower outside, then go into the hot water tub, come out, the next member will come, have a shower, then use the same hot water because he is conserving water and he is conserving energy. So these are the practices which evolve when we start pricing properly, using it as a strategic tool. Now, I said wastewater, fresh water, and water use, but then there's something else with the water coming as rainwater. Sometimes it floods, it creates havoc, and the next day it goes away and we need water. There's no water left. So first thing is harvesting. Water harvesting is becoming popular in cities now by legislation, not by choice. Because people are forced to do that, then they will do that. But in a very limited segment. But what after harvesting? Right now I'm talking to you from a house in Shimla and I have a garden below. So the entire roof collects water, it goes into the storage, and the entire gardening is done on the rainwater. So this is rainwater harvesting. But then you can go a bit beyond that, which is called the groundwater recharge. So if you build structures which gather rainwater, make a large pond, that much water is prevented from going down and flooding. So the larger the number of such rainwater harvesting structures you build, the larger is the quantity you withhold from flooding. And that water slowly, gradually seeps into the ground and makes a groundwater recharge. So our groundwater shall not deplete. So this has to become an essential part of the planning of the smart city. And then, of course, water bodies management and recreation. I stay most of the time in Chandigarh, and that's where Nater is located. And just behind Nater, we have a large Sukna Lake, which is a man-made lake. It has a great significance in life of the Chandigarh people and a greatest attraction for people who visit Chandigarh from outside. But let me confess, with all the institutions of excellence like NITR, like Punjab Engineering College, the Punjab University around, the water quality of the lake is extremely bad. So I do feel concerned about the lake water, which makes it a mud lake. Not that we spoiled it, but this water comes from the hills, carries a lot of sediment, eroding the hills, slopes, and that entire mud water comes into the lake body and keeps on adding it year after year. Let me say one thing. Older days, when we had small ponds and many times the wells, we would put some alum, fitkari, alum, into the water. It settles down the sediment. The water becomes clearer, greener, or bluish rather than brown muddy water. It's a big difference that it makes at once. Though it may not be enough, I would like to talk to you in a while. What more can be done about it? So let us go from the smart water quality management. I said, switch over to ozone, promote pricing to conserve water, promote recycling via membrane and ozone. Do incorporate the water harvesting and recharge. But apart from that, when we come to water bodies, the lakes, the streams, the ponds, the wells, we need still more to do. So let's start with lake because I mentioned about Sukna Lake. It's close to my heart. So why should I restore the lake? First thing is obviously I said it looks bad. The tourist comes there with great hope, finds mud water, no good. Now, my first objective should be preserve the water quality for eco-integrity, which means a wholesome development of the water body, which includes preservation of aquatic resources. There should be good variety of fish or other water life, aquatic life in the lake. We must be able to restore the native species which are dying because of the sediment. Avoid non-native or invasive species. Let's not allow them to come in. Then address the ongoing causes of degradation. Fortunately, in Chandigarh, people are not throwing garbage into the lake. But in many big places, very good lakes have been spoiled by people who throw or who just throw wastewater into the lakes. So this is not happening here, but again, this has to be addressed. Then deploy the natural methods of fixing these causes of degradation and also anticipate future changes. Design for self-sustainability, feasibility. Develop clear and achievable measures of goal. If you're trying to launch a lake restoration plan, these are the essentials. Don't burden your mind. Don't get bored by jargon. These are very simple things. We want a good lake. We want nice fishing. We don't want very good boating inside. And we want to do it naturally. We don't want to throw many chemicals to improve it. So principles of lake restoration, please keep in mind. This is replicable. It's not only for Chandigarh, it's replicable all over. Wherever you have water bodies around you, while planning smart cities, they can become a major source of recreation and tourism if this initiative is taken up. And how to do it really, we need to have some techniques. For example, if you have a motorboat, please throw it. Use a solar boat. If there is a rainwater or storm water entering into the lake from all around the periphery, we need to prevent the entry of contaminants along with the runoff waters. So let me give you a very interesting example of Lake Biwa. Lake Biwa is close to Kyoto where I lived. And in fact, half my time I was stationed on the lakeside. We had a research lab there. And this lake is second largest in the world after Lake Tanganyika in Africa. And it is a drinking water lake. The entire prefecture means a little version of a state in our case, met its drinking water requirement from this lake. And the period of residence of a contaminant entering into lake and going out of lake was 105 years. It's such a large lake. If I throw something, it'll take 105 years to come out. So by the time it would already have been degraded. But the pristine quality of water was being maintained for drinking purposes. And how was it done? Along the entire periphery of the lake, there was a garland drain which received the runoff waters. And it had upflow filters. Normally, filtration is across the filter membrane. But here, the water is entering into the garland drain. From there, it is getting into the lake. And you have filters on top. So everything has to pass through the filter upwards, then go into the lake. So everything that is not good for water is retained in that garland drain and it is sucked out from there. It's very expensive, one may think, but ultimately when you look at the results, it is very cost effective. So this is one which is ideally suited for lakes like the Hyderabad Lake, which is right in the middle of the town, or many others like that, and particularly the hill lakes which are along the slopes. In my case, I would say Lake Renuka in the Sirmaur district. Then you can use organic flocculants by putting just 1% by volume or weight of the entire water body. You can get the entire sediment settled down. Most important is aeration. or oxygenation for water quality. If you bubble through air, the water contaminants would get oxidized and they'll settle down. The best example I have come across of this is Lake Geneva, which has regular diffusers, air diffusers, running below the bottom of the lake, and they continuously give air coming from bottom to top. And during winter, when it is difficult to oxygenate by using simple air, they sometimes put concentrated oxygen also. And that is how they are maintaining that quality of water for which Switzerland is known. And you can imagine the entire economy of the country depends upon Lake Geneva and Lake Zurich. And if we consider that, it's not a big expense. So aeration is a very cheap method by now. When they did it, it was very expensive. Oxygenation was a mad option at that time, but today it is absolutely possible to do it at low cost in India. We will specifically discuss this a little later. Then is aquatic biomass harvesting. You must have the harvesters which keep on taking away the algae and the biomass, harvesting it from the lake so that it doesn't rot in the water and the water quality remains intact. Desilting dredging is common. We are doing already in Lake Bakhda, for instance, and many other reservoirs which are large lakes. Now, we need to monitor the water quality at a mud-water interface to use the small macro and micro invertebrates which grow at that level. They are very good bioindicators to tell you how good or bad is the quality of water. Then there are bioremediation techniques which we are not going to discuss today, but we will discuss aeration and oxygenation for water quality. So generally we have the aeration techniques and equipment like surface aerators and fountains. See, if you have in the middle of a lake, a fountain which takes, sucks out water from the lake itself, throws it up, throws it back, it is gathering oxygen from the air and the water is getting aerated. It will come into water as dissolved oxygen and improve the water quality. Another method is the movable jet aerators. You have small boats with a air jet loaded on both sides. So it keeps on throwing air downwards into the lake, and which again gives the same effect of oxygenation. In the industrial water treatment or the sewage treatment, we use the ceramic discs, which are coarse or fine diffusers. The objective here is that when you are using a surface aerator or a jet aerator, very little water, oxygen is getting transferred into water. Lowest in case of surface aerator, little more in jet aerator. But for the diffuser, the bubble slowly travels upwards. If there's a fine diffuser, it's slower than coarse diffuser. So it takes more period of residence, which means more dissolution of oxygen into water. So we have also the membrane type fine bubble diffusers, micro bubble aeration, but the most noteworthy is the nano bubble diffusers. Now, why this? I would like to explain to you. If there's a big bubble, it will simply go up within a few seconds, and more bulk of the air will go into the environment back. So you are using a compressor to push air, and that air swiftly goes up through the water. It doesn't contribute much oxygen to the water. So as the bubble size goes on reducing. It will go slowly upwards. It will have more surface area, and which means it's more efficacious. Now, interestingly, as you go on making smaller and smaller bubble, the period of residence increases, which means the transfer of oxygen into water increases logically. But if you made the bubble size so small, of the order of 100 or 200 nanometers, at that stage, the bubble doesn't go up. It follows what we call a Brownian motion inside the water. So you keep on floating inside the water body, maybe for months together, until it is entirely dissolved and consumed by water. So nanobubble is a major breakthrough, which makes it possible for us today to aerate our lakes and water bodies. Also, it has application in the city water supply systems. So we will be discussing nanobubble a little more onwards. So you can see in this case, if there's a large bubble, goes up, disappears fast. If there's a micro bubble, means very small bubble, it goes on shrinking because it is getting dissolved in water and finally disappears near the top. But if it is a nano-sized bubble, it continues moving inside the water. It will never leave the water body. So this is a solution which is path breaking, which is game changing. So from a merely 10% or 8% transfer of oxygen, I will go up to 95, 96% transfer of oxygen, making it very, very cheap for me. Particularly when I'm using ozone, the cost saving is much more. So that is significance of bubble size and why we need to use nano bubble technology. So now that when you go back, you have something to carry home, that is nano bubble. First thing you carried was no chlorine ozone. If you did that, half the job is done. Now, since somebody might tell you ozone is very expensive, use a micro bubble or use a nano bubble. Nano bubble, for instance, in India is not prevalent. Micro bubble is already being used in the aquaculture in a small way. And my foundation, the Cleantech Foundation, has the exclusive rights for nanobubble introduction in this country. So if you need any help on this, we are there to help you, and without profit motive. So let us see further. You know, if you look at the diameter of the bubble, the mean size is 1 micron. If you are going smaller towards nanobubbles, and on the right towards micro bubbles and large bubbles. So 1 mm bubble size is a visible size. You can see the bubbles going up. When you go below 100 micron, something like 10 to 100 micron, then it looks cloudy. The bubbles are not distinctly visible in their shape, but they make this entire water body cloudy. Good sign. Now, as you go below 1 micron and towards 100 nanometers, the water becomes transparent. You don't see those bubbles. They are so small. But if you use a light, it scatters the light. So you can detect the bubble there, but you can't see it. And this, as I said, is going to stay in the water body for months together. So the entire season can keep on treating the water body, and it can keep the water quality very high and oxygenated. In fact, many of us who go to the spas for the treatment, What they do, they give you the oxygenated water. So you can make the entire water body oxygenated for the visitor at almost no extra cost. So as you go below 10 nanometer, it shrinks and disappears because they are so small that they are consumed very fast. But nothing goes out of the water body. Everything gets consumed. So smaller the size, if you are below 100 nanometers, you can have something like 98% utilization of oxygen or ozone or any expensive gas, including chlorine. Though I say don't use chlorine, even if you are using chlorine, please dose it in nanobubbles so that it gets consumed entirely. So nanobubble aeration technology has the following features. It saturates water 80,000 times more than other traditional aeration systems. 80,000 times. Not a joke. And this is why I call it a breakthrough, a path breaking technology. The US EPA uses it to control the algal nuisance. If there's a lot of algae growing, you can oxidize it by using this technique. You can remove toxins. You can kill bacteria and microbes. And then, along with nanobubble, if you're using ozone in place of oxygen, any kind of wastewater, howsoever hazardous, toxic, or infected, it will get cleaned up. And best use can be the hospitals, the swimming pools, apart from, of course, our drinking water supplies. Then it prevents anaerobic muck and sediment. You all are aware of the anaerobic treatment, where a lot of bottom sediment occurs. So which when shaken again spoils the water quality. The air or oxygen or the gas can stay within a water column for months together, I said. 4 times greater BOD removal in kilogram per hour. Most of us are today facing a problem that we have 30 BOD requirement for treated wastewater. But the NGT now insists on 10 kg, 10 ppm, which means BOD 30 is now reduced to BOD 10. Already people are not able to really comply with 30 BOD. So it is almost impossible to get into 10 BOD. So that's where this kind of technology comes very handy. And more than 80% total suspended solids are removed by this method. It's visibly better overall water quality and up to 70% reduced energy consumption. So otherwise you are pumping in water or gas or chlorine like mads. And if you can have something like 4 times BOD removal and 80,000 times saturation of water with the gas, well, it's a great thing, and it will save you energy. But then now you need very little gas to be diffused into the system. 70% reduction of energy has been testified in this case. So this is, we can rush through faster because it is a little repetitive. Nanobubble advantages are there. But then, you see, the simple example which I wanted to give was a nanobubble of 100 nanometer is about 2000 times the surface of the same volume of microbubbles. So our normal microbubble generators generate a surface area 1 by 2000 times of what a nanobubble would do. So that kind of a big difference it makes. So with these two things you taking home, I like you to get into more things. And before that, show you On the left is the lake, the natural water body, before the treatment with nanobubble. On the right side is after the treatment. So you can see it removes the algae, it removes the surface contaminants, it removes the suspended solids. The water is blue, water is clear. And you can, the added advantage here is with the oxygenation of this water, the grains would grow rapidly, very fast rate, and it will bring about dramatic change in the ecology around the water body. If Sanjay Sharma and Amit are listening, I would like you to submit a proposal for eco-restoration of Sukna Lake. I discussed with people in the top administration. They've shown a great interest into this. I think NIT TTR must take this initiative right away. And I'm sure our friends from Chandigarh Smart City organization, they are also going to be with us on this. Now, another initiative I'd like you all to take home is a subcritical water reactor. Amit, you will tell me in little in advance when we are exhausting time. We can go faster in that case. But I would like
Sure,
to
sir. Sure. We are having, sir, 15 minutes.
50.
15, sir. 15, sir.
15. So I have to go faster. So the another initiative which I want you guys to take home is subcritical water reactor for multiple applications. Now let us first see what a reactor is like this. This is a subcritical water reactor, which is a, you can see the cylindrical vessel. It is a high pressure vessel of 2 cubic meter size. So the substance to be treated is put inside this, and steam is injected at a very high pressure, and that does the magic. Now, how does it do the magic? Let's come back to the technology part of it. So, inside a vessel, when you are injecting steam, the pressure rises. You don't allow the pressure to come down. So as the pressure goes up, the curve is going up, you can see. So around 100 degrees onwards, up to about 120 degrees, is the extraction range. If you put lemongrass in that water, you'll get the lemongrass oil. If you put eucalyptus, you will get the eucalyptus oil. Which means taking out those oils, selling them, and making the residue easily treatable and usable, reducing the environmental impact. So oily wastes are very bad contaminants. Here we recover the oils for a price, and the residue can be used still. Example, let me go to this next step first. If we are going 130 degrees onwards, the corresponding pressure is also going to rise. So automatically we get into super hydrolysis processing, which means the cellulose which comes in it gets hydrolyzed very fast. Now this is to give you the best use of this hydrolysis. If you have the wheat straw, parali, which is a big nuisance today, all over the country, people are talking about the nuisance of air pollution in Delhi because of the parali being burnt in Punjab, which is, we call it stubble burning. So the stubble burning causes severe air pollution. Instead, if we put the stubble or the parali inside this chamber, in less than 30 minutes, it will get hydrolyzed. Means the entire cellulose available in that straw will be converted into hydrolyzed sugars, right? So these are fermentable sugars. the starting point, wheat straw, put in the, and don't get overawed by the subcritical water name. It's like a pressure cooker, let us say. At this range of temperature and pressure, it becomes hydrolyzing, which means it will make natural sugars, converting the cellulose available in the straw, convert them into sugar, which sugar will be fermented to produce ethyl alcohol. So we can convert the entire straw into ethyl alcohol. It's a very big game changer again. So it has to be brought in, the technology has to be demonstrated, and it has to be proven to our people so that they adopt it. But then, before commercialization, the best potential user for them would be the smart city organizations. And where will this smart city use it? We will come to that. Just running through the next phase at a higher temperature of 250 degrees, it will convert everything into carbon. If you put the same stubble or parali into this, bring it to this range of temperature pressure, it will become charcoal or it will become activated carbon. If you still go higher, 330 degrees, it will become gas. So everything will get gasified. So you can put it through a gas burner, utilize it for generating steam or generating electricity. And the last is the critical point. That is the area above this critical point. Any hazardous waste will be destroyed. Now, consider this technology in comparison with incinerator, where we burn everything, create a lot of air pollution. Here we are doing the same. After all, what is burning? Burning is oxidation. And what we are doing here is also oxidation and hydrolysis. And this is done in a closed chamber, which means no emissions of any kind. And this can be compared as you can call it incineration without fire. We are doing it in steam. So it is a zero emission technology. You can make, you can extract oil, you can hydrolyze, you can carbonize, you can gasify, and you can also destroy into elemental form. That is at the critical point. Now, I will come down to uses. Where are you going to use in a smart city? That is important. So it is a multifunctional reactor with many uses. If you use waste wood, it can be torrefied into cattle feed. If you use agroforestry waste, you can convert into ethanol. If you use wood chips, you might be able to make activated charcoal. If you put hospital waste or medical waste into it, it will be completely destroyed. And if you have a sewage treatment plant, a large sewage treatment plant, which generates a lot of sludge every day, then this is the best treatment for that sludge. It will deactivate that sludge and give you easily disposable, safe compost in less than 40 minutes. So, another very important feature, which I forgot to mention, is you can feed it with all municipal garbage, all sorts, without sorting. Normally, segregation of garbage is where we fail. Here you don't have to segregate. Just put everything into this chamber, and in 40 minutes again, it will completely destroy everything, make it a topsoil, which is a good fertilizer by itself. And whatever plastics, polymers are there in the garbage, you need not separate them. They will be recovered as oil, right? They will be recovered as oil, I repeat. So you don't have to separate plastics. If there is glass, if there is metals, they will come out at the bottom. They can go be sold to the recyclers straight away. So this technology does away with segregation. It's a complete treatment process by itself. It makes it to the Euro standards safe for disposal. And the cost of treatment is very low compared to an incinerator or a composting plant. And the nuisance of composting plant is also obviated. So one application of this could be just to put pure plastics waste into this, and you will convert it into diesel, and which is a storable energy. And it's a complete safe recycling without emissions of all kinds of plastics. And there are certain kind of plastics like the bakelite, etc., which are not going to be destroyed in this case. They will come out along with other recyclables to be disposed of to the recycler. So this is to give you an overview of a technology which can be applied to hospital, which can be applied to municipal garbage, which can be applied to plastic waste, which can be applied to many other applications. Sky is the limit, including the agro waste, which can be used for extraction of very good aromatics, and which can also be used after hydrolysis for making ethanol. So this is the multiple uses. So I want this technology to be carried home by you, and you're at full liberty to get back to us, to the NIT TTR, if you want any support or any further information on this. And of course, it's not something which you can right away react to, but when you go back, think over it. You can use it for using all the waste paper available around you, convert it into ethanol. You can even use it in industry for manufacture of pulp and paper by putting the wood chips or the agro waste into this, and by separating the lignin from the cellulose. So these are some of the visuals. I'm going to not put all of them, but you can see the dehydrated sewage sludge. So when you take it out at a temperature of 185 degrees, by the waste heat itself, it gets dried up. So there's no need of drying beds. This can be straight away put to bags. It can be sold as a fertilizer to the farmers, which is absolutely safe. Even if it had any contaminants, they shall be destroyed and oxidized in the process. These are some visuals of the fertilizing effect of the dehydrated sewage sludge after treatment. And these are reaction mechanisms which let us not bother about. These are all the uses to which this equipment can be put. Of our interest is the municipal waste, the hospital waste, the hazardous waste, and then, of course, the agro waste. Now, if we have any time, we'll just briefly talk about eco-material. This is very, very important. When you're planning a new city, you need materials which are longer lifespan, which are easy to recycle, which have low environmental impact during its manufacture. And most of us are doing a limited work on it as fly ash bricks. That's become very popular. But again, there's a lot more than fly ash bricks in terms of eco-materials. And eco-material has to be renewable, recyclable, non-toxic, non-hazardous, locally available, secondary derivative, and ideally generated from waste. So let me show you some visuals before that. So this is all over applicable, the eco-materials. Let me mention specific materials. Yeah, eco-materials for solar tiles. Now this tile on the right is made from, this is a Japanese product, made from waste tire rubber. The panel is fixed into that. Now these rubber holders, the frames, they are such that they can be stuffed one above the other. They can very easily assemble the roof. One man can assemble the entire roof in a day, and it can generate enough energy for the entire household. Sustainable buildings have to be kept in mind. As I said, not only solar, also it has to be solar passive. This is a solar passive building, which doesn't require much energy for illumination or for heating. These are some more buildings, and this is an example of the Godrej Green Business Center. It is, if you have seen it in Hyderabad, it has an international award for green building. Now, one important thing which you need to keep in mind is when you are designing a city, when you are planning a city, the largest segment of waste to be generated without much use like others is the concrete. So a very strong segment has to be how to use the waste, the concrete waste in the construction material. You all are probably going to visit the Nekshan Garden, the rock garden, and you will get many ideas how this can be done. But it can be done on an industrial scale also, making an entire range of building materials which are based on construction waste. Our team, Dr. Sanjay and Dr. Amit, will talk to you about sustainable concrete, the polymer concrete, the low weight, high insulation concrete, which can be of great use in making high-rise buildings, which have to be energy efficient. So this is another very important area of concern. Now, this is a very small example, but very interesting. I always share it. This is on the right is simple. Can you see what this is? This is the fiber cable, optical fiber. So on the top, it is catching the light of the sun. So it is flowing through the fiber, and inside from the tips, it is the light is being dispersed into the room. So this is a zero cost illumination for all times to come. So this is a very small innovation, which is not something a rocket science, but this can be done in all buildings, particularly the let's say private buildings, government buildings apart. I have seen a very similar example in the Dharavi area. Most of those jugis, they cut a small hole in the tin roof, and then they put a plastic bottle inside it, push it, and that light comes from on top. It's just like having, a free electricity lamp inside your house. So that's again innovation. So innovation has no scale or cost. So advanced materials for sustainability are very important things. And the most important, but since the time is short, I would like to take with you is the smart glass and the solar films. With the film technology, the cost of solar energy generation is going to be very low, and this film can be pasted on your normal rooftops very easily. And these films are already in the market. The original inventor was an Indian who lived in Switzerland, who's died, but the product is called Konark. It is still in the market, not become very popular so far. Then again, there is something called smart glass. Now, a glass needs many characteristics. If I have a window pane in a high-rise building, I can't clean it. So I need a coating where it becomes self-cleaning, where it becomes anti-fog, where it becomes anti-rain, where it becomes adaptive to sunlight intensity. It will become tinted when required. it will become normal white, transparent when required. And another very important technology which I like to mention to you is the what you call the silicon dioxide coating, the nano coatings on glass, which make it absolutely what you call the insulating material. And when you see these glass buildings in US, they are not actually glass. They are sandwiched two glasses, and inside is a layer of silicon. So which is what you call is the I will just show you we call it aerogel. Can you see this aerogel? Now this is nano material. A block of aerogel 500 gram in weight would support half a ton of load. It is so strong, it is so light, it is lighter than air almost. If you throw it up, it comes down slowly. And if you look at the picture on the right, this is the sheet of aerogel, silicon aerogel. And from below there is a steam, there's a flame, which is oxytorch, oxyflame, used for welding. And you touch the top, it is cold. So it's such a unique product in insulation. So all our buildings in the smart city need to have aerogels, both on the coating on the glass and as insulating materials along the roofs and walls. So you can make light structures, which are rather than making thick walls, you make thin walls with this insulating gel. They'll do the same job and will be lighter as structures. So the aerogel feels like a polystyrene. It's very light, very strong, structured, remarkable thermal insulation, good convective inhibitor, good conductive insulator, good radiative insulator, and a sound absorber. Noise is also a very important feature, which is addressed by this. So you are carrying home aerogels also as material. You can see how this is used so easily. It's just like a greenhouse. You're using the panels of aerogel, which are very thin, very strong, and which are very, very effective. This is a building fitted with translucent silica hydrogel panels. So this is the future smart city. This is called a smart city. And then two more materials which I mentioned to you is carbon fiber and fabric. When the Kyoto earthquake took place, the highway designed for 9.5 Richter, it collapsed at 8 Richter. So the entire government of Japan was disturbed, and they conducted study what was failing in design and what could be done as remediation of future protection measure. Carbon fiber gave the answer. It was used as a reinforcement material in place of steel. You all have seen carbon fiber tennis rackets, carbon fiber bicycles, and these days the aircrafts are made of carbon fiber and fabric because they must be light in weight, but should be stronger than steel. So carbon fiber is many times stronger than steel, much lighter than steel, and it's a futuristic material. But this is not futuristic, I dare say, because this is already going to be overtaken by yet another material, which is nanocellulose. So nanocellulose is a fiber which is stronger than carbon fiber, lighter than both steel and carbon fiber. And on the right bottom, you see a car, which is a concept car made by the Japanese. It is made of nanocellulose, or in other way, other language, you can say it is a paper car. Same material which is used for making of paper. In fact, I can use paper as my starting material, creates a nanocellulose very easily, and then that can be spun into a fiber, and that fiber will make these nanocellulose bicycles, cars, aeroplanes, and including the future structural bridges and buildings too, and be very, very lightweight. This is again future. We need to know these things when we are planning a futuristic smart city. The application may be very little. I'm sure sometimes people are not going to listen to you, but these are things we need to continue pushing. And similarly, 3D printed bio-based materials, and which are little away still. And at the end, I would conclude by saying, building smart cities is a continuous process that shall never end. Thank you very much. Am I in time, Amit?
Yes, sir. Yes, sir. You're in time, sir. Thank you so much, sir. Just a moment, sir.
So what I'll do is I'll escape this so that I can see you guys.
So, dear participants, do you have any queries? So you can ask. If you are having any queries, dear participants, you can unmute yourself. You can unmute yourself. Dear
All right,
participants,
there must be overdose today, and maybe you can always ask us questions anytime later. Connect with Dr. Amit or Dr. Sanjay, and through them I am always available to you. Right?
so if the participants are not having any queries, so I would like to thank Dr. Ashok Sharma for sparing his valuable time and interacting with our participants. I think he has always been an inspiration to many, and including me, because he is having a lot of ideas. And just before this lecture, he also, I am lucky enough that he narrated one. He shared one idea with me, so that we can work in the state of Himachal Pradesh, and because of his experience and his expertise, so we can always take help from him for solving any problem, because he is having vast experience in technological intervention, in using of the technologies and application of the technologies in the field. So thank you so much, sir, for sparing your valuable time. And now Dr. Sanjay Sharma ji is also coming, sir. Just a moment, and after that we'll close. In the meantime, if any of the participant want to say anything, so you are most welcome. Any participant? Dr. Kaleem? Dr. Kaleem? Dr. Kaleem, are you there? So, anybody? Madan Sharma ji?
Okay, then I think we can always continue to be in touch. They can always, the window is there. You can all get in touch with Dr. Amit, and through him, I'm always available to you to answer any of the queries anytime. Right?
Thank you so much, sir. Thank you for your introduction. Thank you so much, sir. Now I'd like to request, sir, Dr. Sanjay Sharma is also there, sir. He would like to thank you, sir.
Okay.
Thank you very much, sir. I think for your time and for your valuable inputs. And as some of the things we will try to see that, okay, that like you were asking about this initiative on lake. So
yes, that is a must. Yes.
How it can be, whether
we can do this. I think we will ask Dr. Harish also to join in for drafting a proposal. Because he's going to be on the other side. And Narendra Sharma has already spoken to us.
Yeah.
He will also be willing to support, and so will be Mr. Dalai.
Yeah.
Thank you. All the best.
Okay. So thank you very much, sir. And I think we'll be sending you some, that project are also working, so I will send you that by tomorrow.
Okay.
Thank you.
Great.